Take a look at this. On the first look, one might conclude that there are two terminal sessions. And that would be correct. On the top is a Z shell session where we can execute commands and scripts. There is nothing special about it. The bottom pane, however, is something completely different, yet somehow the same. Over there we can also execute commands and scripts, but that's only the tip of the iceberg. What you're looking at is not only a shell session, but also a programming language focused on managing data. It's a shell, a language, data, it works everywhere, it contains everything one might need, and much more. It is a very special project that might change the way you operate. It is Nushell. I have two terminal sessions opened. The top pane is Z shell. It could have been Bash or any other shell. Within the context of our subject, they all work the same. Below is a Nushell session. That's the special one we're exploring today. Now, let's say that we would like to list all the files and directories. Anyone who ever used a shell, at least on macOS and Linux, or WSL, knows that we can do that through the ls command. If you would like to get more information, we can add the -l argument. As I already said, there is nothing special about the ls command. It's boring common knowledge. Now, let's take a look at how boring looks like in Nushell. The output of ls in Nushell is definitely prettier. It's organized as a table and it's full of colors. That's great, but who cares? I could accomplish a similar result with ESA or some other CLI replacement for ls. That better output alone would not be worth my time, and I would not dare to suggest that you should change your favorite shell, whichever it is, just so that you get prettier outputs. There is much more to Nushell, and it all revolves around data. Let's take a quick break to introduce you to Renovate, the sponsor of this video. If you're not using Renovate, you might miss one of the most important services. It's one of those I could not live without. It automates dependency updates, which is potentially one of the most demanding tasks one can do manually. Instead of waiting until your dependencies are so outdated that you cannot even update to the recent ones, Renovate does that for you by creating pull requests with updates that match the rules you specify. Mend hosts a free Renovate service for github.com and Bitbucket Cloud via their app stores, and they also have commercial community and enterprise editions available for GitHub, GitLab, and Bitbucket server. I strongly recommend it. Try it out and let me know what you think. Thank you, Mend, for sponsoring this video, and now let's get back to the main subject. Let's say that we would like to list only files from the current directory, and that for whatever reason we want to continue using the ls command baked into every shell instead of opting for some more advanced alternative. How would we do that? One way to accomplish that would be to list all the files and directories with ls-l and pipe the output to egrep that will keep all lines except those starting with D. That worked. Somehow. What we saw is the cornerstone of Linux and pretty much any other operating system. Much of Linux is based on the concept of pipes. One command generates the output that is passed as input of the next command. And that's truly great. But there is a problem though. All the commands output text and only text, and that leads to often complicated situations. Text is hard to filter, even harder to transform, and close to impossible to sort. Still, that's how everything works, and over time we'll learn how to deal with it. Nushell has a very different approach to piping. Commands do not output text, they output data. When we executed ls and got that pretty table, we saw a graphical representation of data that can be manipulated in a very different way than text. Let's try to accomplish the same objective of retrieving only files, but instead of using grep to sift through lines of text, try to accomplish the same outcome by leveraging the fact that Nushell outputs data. To do that, we can, for example, use the where command baked into Nushell. Let's see what where has to offer. The first thing you will notice is that the available help is much better organized and easier to digest than with other commands, especially those baked into shells. The second thing you will notice is that there aren't many arguments, not only in the where statement but any other Nushell command. As you'll see later, there is no need for endless arguments since Nushell relies on passing data through pipes to accomplish the end result. Still, the goal is not to admire Nushell help, but instead to retrieve only files from the current directory. We can do that by executing ls, which, as we already saw, retrieves all files and directories and outputs them not as text, but as data. From there on, we can pipe that data to the where command that will filter it by the column type being equal to file. We still got a nice table-like representation of the output, but this time it shows only files. That's awesome, yet you might be thinking that alone is not worth the switch. It's true that grep might not be as intuitive and as user-friendly as what we just saw with Nushell. Still, you're used to grep and it works everywhere. That is still not enough to make a switch to Nushell interesting, especially since it is not POSIX compliant. For now, what matters is that unlike typical shells that always output text, Nushell outputs data. That data might originate from almost any format, and Nushell will transform it into its own that can be used as input for other commands through pipes. Let's go a bit further and say that we would like to retrieve only files that are bigger than 1 kilobyte. How would we do that? In the traditional Z shell or bash, such a simple task would already become complicated. We are probably going to need to abandon ls command and switch to find, and once we do that, start practicing witchcraft and wizardry to get what we're looking for. Alternatively, we might be able to accomplish that objective with some replacement for ls or find. With Nushell, on the other hand, such a task is very easy. We can list the files and directories with ls, pipe it to one where statement that will filter data from ls so that only files are retrieved, and finally pipe that data, final data, to a second where statement that will filter data so that only the rows with the column size greater than 1 kilobyte are retrieved. So far, what Nushell does looks similar to SQL, except that the output of any Nushell command is data and that data is passed from one command to another through pipes. Let's continue. Actually, we will not continue with Z shell since the previous task already proved to be too complex for my little brain. So I'm abandoning Z shell and will continue with Nushell alone. Now, let's say that we would like not only to retrieve files bigger than 1 kilobyte, but also to sort those files by size. We could do that by repeating the previous command and piping the resulting data to the sort by command. Look at that. That's great. We got files filtered and sorted by size, but that's not really what I wanted. I made a mistake. What I honestly really need is to sort files by size from the biggest to the smallest, and the output in front of me sorts them ascending from smallest to largest. We can fix that with the reverse command. And while we're at it, let's split the commands into multiple lines so that they are easier to digest. So, here we go again. There's ls, and if this would be Z shell or bash, we would add backslash at the end of the line, but we don't have to do that with Nushell. We can just press the enter key to go to the next line, pipe it to the first where statement that applies the filter so that only files are kept, a new line again, pipe to the second where, new line, pipe to the sort by, and then new line again, and finally reverse the order. Wasn't that something? If you don't think that what we just did is awesome, I dare you to accomplish the same result with ls and grep and whatever else you might be used to use. Do it. Do it right now, and I will wait. Was it a success? If it was, how many sessions with Psychologist do you think you will need to suppress the experience you just had? Now, let's take a look at the commands available in Nushell. That's nice, right? We can easily see what's available, but that's not why we executed it. Instead, I want to demonstrate one more time that all Nushell commands output data that can be manipulated. We can, for example, retrieve only the ls command by listing all commands and piping the output data into where so that we filter it by name being equal to ls. Here's the important thing to note. When we retrieve a list of data, we get only a fraction of the information. That's similar to executing, let's say, kubectl pods that returns only a few fields for each pod. If you would like to see all the data related to the pod, we should retrieve one pod and output it to YAML or JSON. Nushell does something similar if only one record is retrieved. So let's take a look by repeating the previous command and piping it to first. That limits the output to only one row, the first row of data. We got all the information about the ls command, and we can go even further and let's say pipe all that to get params so that only the params field is returned. We can also use a shorthand syntax and just envelop the whole command in braces and just say to get params without the need to pipe it to get command. And the output should be the same. We can use the same logic to manipulate data in files. For example, we can open settings.yaml file. Now let's say that we are not interested in the whole file, but instead that we would like to retrieve the production.azure.location field. Since the open command, just as any other, outputs data, we can get what we need by piping the data from the settings YAML file to the get command to retrieve what we need. Okay, so far we saw that Nushell is pretty and that it outputs everything as data. But there's more. There's much more though. Nushell also comes with all the bangs and whistles that we would normally need to add ourselves to whichever other shell we might be using. For example, I can type let hyperscaler equal get-hyper and press the tab key to autocomplete it into get hyperscaler. The output allows us to select one of three hyperscalers. Besides the autocomplete functionality, which by the way works better than in any other shell, you might be wondering what is the get hyperscaler command we just executed. Does Nushell come with a baked-in command that allows us to select between Google, AWS and Azure? The short answer is no, it doesn't. We'll see how that happened in a moment. For now, what matters is that autocomplete works. As a side note, the let instruction we just executed is how we declare variables. So now hyperscaler contains the value AWS or whichever you might have selected. There's more though. Nushell also comes with excellent error messages. Unlike typical shell commands that often leave you wondering what the heck is wrong, Nushell, due to reasons we'll discuss later, knows exactly what's wrong and it is not afraid to tell you. Here's an example. That command was supposed to output text with the value of the hyperscaler variable painted as magenta and in bold. However, Nushell correctly identified that I made a mistake and used an ANSI code that does not exist. I wrote magenta bold instead of magenta bold. It should be T instead of D. Okay, now that we know what exactly is wrong, we can correct it and run it again. So far, we saw that Nushell is pretty, that it always outputs data. It also contains all the bells and whistles we would normally need to add ourselves to whichever shell we're using. That would be autocomplete we saw earlier, but there are quite a few others. Finally, we saw that it knows what exactly is wrong, if anything is wrong. Now, what does that level of information output on errors remind you of? Where have you seen something like that? If the answer is languages like JavaScript, Python, Go, and others, you're right. Nushell is also a language. Here's the thing. Everything we executed so far were commands piped to each other, right? Well, that is correct, but wrong at the same time. While those commands act as commands, they're also acting as instructions in a programming language. A set of instructions is validated and compiled before they are executed. Nushell is just as much a programming language as it is a shell, and we saw a glimpse of it when we executed the command that threw an error. We got a notification that something is wrong before that something was even executed. We'll see a better example of that in a moment. For now, let's take a look and apply a definition I prepared. That code block defined a new definition that acts as a new command. It defined a variable hyperscaler that will get the output of the command. That command is a list of values, Google, AWS and Azure, which is piped to input with a text that acts as the header. That text will be in green and bold, and whatever comes after it will be in yellow. Further on, we are opening the settings YAML file that outputs YAML as data. Then we are upserting the value of the hyperscaler variable into the hyperscaler key in that YAML, and finally we are saving the data back to the settings YAML file. At the very end, we'll output the value of the hyperscaler variable back to whomever will call that new command. Let's run it. Again, we already ran it earlier, but let's do it again. We can see the message, the header, and the choices. If, for example, we select Azure, it is output back to the caller. Also, the settings YAML file was updated. There's probably no need to validate that really happened. You should trust me by now, right? Now, let's take a look at the source code of a new script. It would take a lot of time to go through that whole code here. I'll leave that to you to do at some later time. Instead, we'll jump straight into running it. If that was, for example, a bash script, it would start running immediately and throw an often incomprehensible error once it reaches the instruction with it. Nushell did not execute anything. It tried to compile that script and detected that the ingress IP was not found. Nothing was run since there would be no point in running anything. It behaved in the same way as if we, for example, wrote that code in Go. It could not run if it could not be compiled. Fortunately, I have a version of that same script that does work, so let's run that one instead. This time it worked. There is no compile time error in the code. But there's more though. We can run non-Nushell commands as well. Let us, for example, run kubectl to run a pod and retrieve all the pods across all namespaces. There was nothing special about those commands. Any shell command can be run in Nushell. We call them external commands. But there is a catch though. External commands, those not baked into Nushell, do not output results as data. That list of pods is a text blob. That's what kubectl does. It outputs text just as almost any other shell command does. But we can change that by piping the text output of kubectl get pods to detect columns. The detect columns instruction parsed the text, figured out column headers and column values, and used that to generate Nushell data. The end result is a table similar to other tables we saw earlier. From here on, we can use that data in the same way we would use data generated by Nushell commands. We can, for example, use the where instruction to retrieve only pods with the status other than running. That was one more example of Nushell's precise error messages. We can see that there is no status column and that we should probably have set it to status with all uppercase. Let's correct that and run it again. This time it worked and we got the list of all the pods with statuses other than running. We can continue from there and, for example, retrieve only the name column from those pods. Finally, if you would like to take a closer look at the pod that is misbehaving, we can assign it to the pod name variable and use it to describe the pod. Look at that. And we're almost done. There is only one more thing I want to show. You might find some Nushell syntax a bit confusing if you're coming from other shells. For example, if you would like to split a single command into multiple lines, we would normally write / at the end of each. That does not work in Nushell, and your first reaction could be to ask, why? Using / at the end of a line is widely accepted way to separate lines of a single command. It would make perfect sense for Nushell to respect it, but it doesn't. The reason is Nushell's commitment to work everywhere, and while / can be used to separate or to be more precise, remove new lines in Linux and macOS, in Windows it is used to separate directories. So Nushell does not allow it since it would not work in Windows. Instead, we can use braces to define a single command that can span any number of lines. Here it goes. Here's another example of something that works everywhere. In macOS, we can use open to open a file or a web page or anything else. However, open does not work in Linux and we have to use xdg open instead. I have no idea whether it works in Windows since I haven't used it in a while, and given my age, I cannot remember anything older than a year, sometimes even a day. In Nushell, the command that opens something is start, and it works in any operating system. That, for example, opened the DevOps Toolkit Live in my default browser. It's a site with text versions of my videos. Okay, I think that was enough. I could talk about Nushell for a very, very long time. It's a big project with a lot to explore. And I will leave that to you and finish it with pros and cons. So you explore and I talk about pros and cons. Shells haven't changed much since the dawn of time. Nushell tries to change that. It tries to reimagine what shells could be if we would design them today, and if we would not be bound by standards, like POSIX, established, decades ago? Nobody knows. Nushell merges at least 3 distinct capabilities. It takes a shell and makes it interactive. It combines it with a fully typed scripting language that feels like a combination of TypeScript and SQL. Finally, and perhaps most importantly, it is a data processing system. Piping is based on passing structured data instead of passing text blobs. Every Nushell command outputs data, and almost every command accepts data as input. Nevertheless, there are good and bad sides to Nushell. So let's discuss them, starting with cons. The first and potentially the biggest negative thing is that Nushell is not POSIX compliant. If you have a set of shell commands written in some markdown, there is the chance that they will not be executable in Nushell. A good example is / at the end of a line in multi-line commands. That and quite a few other instructions will not work in Nushell, and that can be annoying since you'll have to learn a new syntax. Now, to be clear, there are probably good reasons why Nushell made those choices. Nevertheless, you might need to prepare for the initial shock, even though it will reap benefits later. Actually, very soon. The second issue is that Nushell replaces common shell commands with alternatives that are not compatible. For example, ls in Nushell lists files and directories just as ls in any other shell does. However, if you try to use arguments like .shell, you will quickly realize that they do not work in Nushell. Hence, you cannot start doing in Nushell what you were doing before in hopes that you'll gradually switch to it. To be fair, most of those arguments are not needed in Nushell commands, and once you get used to it, you will not miss them. Still, there is going to be some adjustment period. Finally, the last negative that I chose today is that completion might be hard to get for external commands, those not baked in Nushell. It is not impossible, but it is often not trivial either. There are other negatives, but those 3 tend to be the biggest ones, at least for me. As for pros, the first thing you will hopefully love about Nushell is that it outputs structured data. That might not seem like a big thing at first, but once you get used to it, and once you realize that you do not need tools like grep, awk, jq, yq, and so on and so forth, you will start to appreciate the difference between outputs being text blobs and structured data. Then we have the language. Nushell is as much a language as it is a shell, and those two are integrated seamlessly. It's like using TypeScript combined with SQL. It requires a bit of an investment to wrap your head around it, but once you do, you might not be able to go back to writing bash scripts. It is not going to replace languages for writing applications, but it certainly can replace your scripts. It's a big improvement as long as you're willing to learn it. It's not hard, and it can be digested fast, so the learning curve is very, very shallow. Being a language brings typical benefits that do not exist or are badly done in other shells. There is type checker, useful error messages, background compilation, and so on and so forth. Next, Nushell comes with all the bangs and whistles you might expect from a shell. There is completion, at least for internal commands, syntax highlighting, and other things that are typically not baked into other shells, but can be added through plugins or other means. That does not make Nushell special by itself. What makes it special is that those are baked in, so we do not need to bother spending time to add them, as is the case with, let's say, Z-Shell. Then we have the fact that it works everywhere. It can run on macOS, on Windows, and on Linux. That ability is one of the reasons why Nushell chose syntax that in some cases might look strange. Still, the commitment to work everywhere is an important one. What else? Oh yeah. Outputs to the screen are formatted as tables, making them very easy to digest. There are cases when table formatting might not be the best choice, like in the case of YAML and JSON, and in those situations we can always add the --row argument that outputs data as is, which results in the same look and feel as POSIX shells. Finally, over time, one gets to appreciate that Nushell commands tend to have fewer arguments. Not because Nushell developers were lazy, but because there is no need for as many arguments as in other shells. Since it deals with structured data, operations that are often fine-tuned through endless arguments tend to be accomplished through pipes. Nushell is well made. It is logical, and it is very, very solid shell and language. The main question we might need to answer is whether we want a shell that is at the same time a programming language and that is focused on structured data. I say yes, a big yes to that. Nushell is not a variation of an existing shell, but a true conceptual change in how we work. I strongly recommend it. Try it out and let me know what you think. Thank you for watching. See you in the next one. Cheers.